that I am a faculty of DIATM. Let me first introduce myself. So I'm presenting my screen. Okay, I am Kunal Roy, and I have qualified GATE 2020 and NET 2022. And currently, I am an assistant professor of CSC department, that is Durgapur Institute of Advanced Technology and Management. And currently, I am working on a research based on DPI technology and blockchain. So, thank you for giving me this opportunity to speak with you today about the topic that is a discriminant analysis. So basically, today we will cover. Basically, I have make in a five-step process for explaining this. That is a discriminant analysis. So basically, we can say that this analysis, or what do you mean by a discriminant and what do you mean by analysis, we will explain first the introduction part. Then we will move into the mathematical equations and preliminaries regarding the discriminant analysis, and then we will in the third step we will move into the types of discriminant analysis, and we will do some implementation regarding a hands-on approach, or we can say that a hands-on application we will do regarding the types of discriminant analysis, and why this discriminant analysis is used and what are the applications behind this analysis. Okay, so first we have to consider, or we have to say that what do mean by a discriminant analysis. So in a simple term, we can say a discriminant is nothing but separating something. We can say a separating something, and after separating something, we will distribute into something. Okay, now what is this something and what are this? So let us take a normal example. Let us consider that there is a fruit basket. Okay, there is a fruit basket, and lots of fruits are available inside this basket. That is apple, orange, and all, and banana and all. So how we can discriminate everything, each and every data, we can say there is a data, or we can say there is a container having lots of data of similar type, but how we can distribute this data into different thing, or in a easy way we can say how we can assume that it is an apple, and how we can assume that it is a banana, and how we can assume that it is an orange. So specifically for this purpose, we will use this analysis, that is a discriminant analysis. So how we can separate these fruits into different parts? So we can say that it can have a size. In terms of size, we can separate the fruits. In terms of color, we can separate these fruits. And in terms of any shape, we can separate this fruit. And a lots of things we can say. Okay, so this separation of data based on the classes or based on the group of populations, we can say, is known as a discriminant analysis. That's why the first point is written as the distinguishing between the two or more groups of population and determining how we can allocate new observations into the group. Now, how we can check that whether it is an apple, whether it is it is a particular fruit or not. So basically, this overall fruits can be considered as a dependent variable. Okay, as a dependent variable. Now what do you mean by a dependent and what do you mean by an independent variable, I will explain with this example only. So the fruits container, whatever we can say, is a dependent variable, we can say, and we have a set of independent variable, that is size, color, and shape. So that's why this analysis is basically to estimate the relationship between the single categorical dependent variable and a set of quantitative independent variable. Now what is dependent variable? Dependent variable is a categorical variable. Okay, it is not a numerical variable. For this purpose, we can say a dependent variable is a categorical variable, and for the independent variable, we can say it is a quantitative approach, or quantitative independent variables, we can say. So as we know, uh, uh, suppose we can say a basic straight line equation as y equal to mx plus c. Okay, so in terms of fruits and colors and all, we can say that y is acting like an dependent variable, and m is acting sorry x is acting like an independent variable. So we can say this x can be a size, this x can be a color, this x can be a shape. So this x is always, will be always a numerical data, will always a numerical data. And this y, or we can say dependent variable, is always a categorical data. That is, apart from the numerical data, we can say lots of categories are there for this. Okay, so that's why the basic approach behind the discriminant analysis is that we can first distribute the population into some classes. That classes can be one independent variable also, that classes can be multiple independent variable also. So depending upon the situation, whatever we are facing, we can use this discriminant analysis. Basically, if we have more than two groups, or we can say more than two independent variables, then it comes under the category of multiple discriminant analysis, or we can say canonical varieties analysis. These two things are same thing, but we have to consider that if we have a set of more than one or more than two independent variables, then we can make an approach of multiple discriminant analysis. But the basic key points behind the analysis is we have to estimate the relationship between the categorical dependent variable and the quantitative independent variable. So next, what could be the scope behind this? Now, how we can use this discriminant analysis in various scopes like this? So we can, I have given some examples like determining. First is including predicting the success or failure of a new product. Suppose a new product is launched. Okay, suppose a new product is launched, but I don't know what type, what could be the result for this, what could be the future result for this product, whether this product can give us a profit, or whether it can give us a loss. So this profit, this loss calculations, or for doing such calculations, or for predicting such calculations, we use this approach, that is the discriminant analysis. So we can say that we can predict the success and failure of a new product also. Next example I have given, that is determining what category of credit risk a person falls into. Next is classifying students as to vocational interest, deciding whether a student should be admitted to a graduate school or not. So as we know that before moving into some bachelor's courses or moving into some master's courses, first we have to complete the 10th and 12th, or we can say we have to complete the 10th is a must. Okay, so how we can assume that whether he will be admitted into a computer science category after the school, and he will be admitted into some another categories. So based on the marks of the students, we can say that he will move into this category. Based on the percentage of the student, he will move into this category. So this marks and percentage are acting like an independent variables, but the dependent variable is taking an admission, whether that student is will be a graduate school, predicting that whether he will be assigned to this background or not, or whether he will assign to this background or not. So that's why we can say that here also some discriminant analysis approach can be made. And at last I can say that an example that a company will be a success or not. Suppose we have a normal startup business. Okay, we have some data, or we have some uh, data before doing any startup business. So whether it will give me a success or not, here also some discriminant analysis approach can be used. Next, when and why this DA is used, how or when and why this DA can be used. So basically lots of things are there, but specifically for the classification purpose, we can use this discriminant analysis. Specifically for the dimensionally reduction purpose, what is this, I will explain in detail. Specifically for medical diagnosis, we can say that it can be used. And specifically for the market research, this is a trending right now, which is going on. So for this approach, we will be using a discriminant analysis. Now how this classification is used for the discriminant analysis purpose. So let us take a normal example like a Gmail. We can take a Gmail. Okay, now lots of mails are coming from lots of websites and lots of something. Now this Gmail is using some approach of discriminant analysis, that is a spam. whether this email is a spam, whether his email is acting like a spam, or whether it is a not spam. How we can determine this? There is a specific section regarding the spam folders, or we can say a spam emails. So how they are classifying that whether that email is a spam email or whether that email is a not non-spam email. So here they are using this approach, or they are developing a model for this. We will also develop a model by using some data sets, or by using some data. Okay, so here the data is acting like all the emails. Okay, then this Gmail is scanning that whether the messages are spam or whether that messages are not spam. So here they are developing a model for classifying these email messages as spam or not spam. So here also a discriminant analysis approach is used. Here we can say that Gmail is a dependent variable, and the emails whatever they are coming, that can be an independent variables. Next, dimensionality reduction. Now, what do you mean by dimensionality reduction? So here, if we have lots of independent variables, how we can handle those independent variables? If we have lots of independent variables, and how we can handle those independent variables, that things comes under the category of dimensionality reduction. That things comes under the category of dimensionality reductions. So we can say that a model can be created for dimensionally reduction, or having to reduce the number of input variables. Now here the input variables are acting like an independent variables. So we can reduce this independent variable by creating a model and try to solve the problem regarding the discriminant analysis with less time. Okay, next is the medical diagnosis. Medical diagnosis can be used to identify the patient characteristics regarding what type of symptom arises for this, or regarding what type of precaution you have to measure for this for a patient. So we can use here also a discriminant analysis. So currently this market research is on trending, okay, which is used to attract the customers regarding their behavior and preferences. Okay, what the customer wants specifically, the online businesses, specifically the online approach of marketing is going on. We can say there is an example, like there is a digital marketing. We can say digital marketing is also one type of model for discriminant analysis. So here they are taking the customer behavior and preferences. This behavior and preferences are acting like a variables, or acting like an independent variables, so that they could analyze that what type of thing the customer wants in a hand, or in presence of a hand. Okay, they do not have to move into the offline purpose, what can be done using the online approach. So that's why this market research is also used for the discriminant analysis. Now, this is the basic thing regarding the discriminant analysis, that total 5 number of steps are there when we discuss about the discriminant analysis. There are basically 5 types of steps, or we can say 5 steps available. So first we have to form the groups, then we have to estimate the discriminant function. Now what is discriminant function, I will explain in the mathematical section right now. Then we have to determine the significance of the variables. Now these variables can be an independent variable or can be a dependent variable. We have to make a function regarding this. Then we have to interpret that function and apply that function for classification and validation purposes. So basically the first step behind the discriminant analysis can be forming a group. That means we have lots of data available. Now how we can arrange those data, or how we can classify those data, so that we can identify or predict what type of data can be coming in next section. So that's why we have to divide the data into 2 or more groups. We have to divide this data into 2 or more groups. It can have many groups, group 1, group 2, group 3, and all, based on a variable that you are trying to predict. Now we have to take a counter variable. That means we have to take a threshold for this. So based on this threshold, we are going to separate this data into various types of groups. So first and foremost step of the discriminant analysis is to form groups using a variable, we can say. So I have taken a normal example like customer churn prediction. That means, suppose we can say an Amazon, okay, we can say an Amazon, lots of customers are given a login ID and passwords, and login ID and passwords. Now from that customers, few customers are the prime members, that means few customers are the premium members, and few customers are the non-prime members. So how we are determining that prime members are giving more credits for this, or prime members will be benefited for this, or we can say prime members are getting more discount from the non-prime members. So how we can identify this? So this can be an approach for a discriminant analysis. Here the Amazon is acting like a dependent variable which is determining the independent variables, that is, which is taking that who are the prime members. I will be giving only the discount to the prime members, so that the market research will be benefited for them, and I will be not giving so much discount to the non-prime members. So how this discrimination is possible for this? So this discrimination between the prime and non-prime members can be an approach for discriminant analysis. So this is the first approach, that is forming a groups. Next is estimate the discriminant function. Now what is discriminant function? We will explain in the next slide. We will take a function which will classify the dependent and independent variables. Just we have to take a function which will classify the dependent and independent variables, or we can say a predictor or response variables. So we can say uh, a discriminant function is acting like, here it can be, it can have an example like Amazon. We can say there is a prime member. Okay, now how we can identify it as a prime member? He will check the history of the prime member. That history will be acting like a discriminant function. Their demographic data, that means in this month how he have purchased, what amount of data he have purchased, or what amount of product he have purchased. So demographic data can be one type of discriminant function. And customer tenure. Okay, now up to how many year he is a prime member, it is also a main factor for it is also can be considered as a discriminant function. So we can assume that first we have formed the group, then we have estimate the discriminant function to analyze those data. Next, determine the significance and variables. Now this is the third phase of the discriminant analysis, that is how we can determine the variables, which are the variables, which are not the variables, how we can determine the variables. Okay, next, uh, interpret the discriminant function. Now I have taken one discriminant function like customer tenure. Suppose I have taken the tenure period of the customer. Suppose you have a 1 year of tenure. Okay, so this tenure is considered as a function for this. As you have learned in your basics in Python that what is a function, so we can determine this as a discriminant function. So we can take a function and try to interpret this, or I try to evaluate this, that using this how we can determine that what type of data can be considered to form a group. So we can say that we can interpret this, or we can clarify this, or classify this discriminant function. So first part is forming the groups, the second part is estimate the discriminant function, the third part is determine the significance of functions and variables, and then we try to interpret that discriminant function. After taking all the necessary steps for the discriminant approach, we can then analyze the data which is used for predicting the future scope of data. What could be the future scope of the data, and what could be the result behind those data? After interpreting all those things, after determining all those things, so thus we have to take care about the determinant discriminant analysis, that forming a group, just a shortcut we can say FEDIP. We can say that FEDIP, it can have a steps like, first is the form groups, then estimate discriminant function, then determine the function and variables, then interpret that discriminant function and perform the analysis. So these are the main steps behind the discriminant analysis. So we have taken a basic example that how we can determine the discriminant function. So let us consider that we have a 50 males and we have a 50 females. Suppose in a particular class or in a particular college and all, we can say that there are 50 males and there are 50 females. Suppose we have distributed this. So here in the picture we can say that this white circles are acting like a acting like a male, and these black circles are acting like a female. So females are on average, if you find the average height, I want to determine that who, what type of percentage, I want to determine that how many percentage of students are tall and how many students percentage of students are short. Suppose we want to discriminate between this and this. So this tall is acting like a dependent variable. Okay, and these males and females are acting like an independent variable. So this tall can be considered, or this height can be considered as an independent variable. So we can take this height or we can take this tallness as a discriminant function and try to interpret this function by calculating, say, average. Okay, so let us consider that we have to find the average of height between 50 males. Say average is coming around say 5.6 or 5.8, it is coming around, and average height of female is coming around, say 5.4. So this average height can also be considered as a discriminant variable between the males and females. That's why I have taken a highlight approach, that variable height allows us to discriminate between males and females. Now we can determine now that if a person is tall, then he is likely to be male, because the average is coming for males, average is coming more for the males. And if a person is in short, then she is likely to be female. Just a probability I'm taking, I'm not assuming that he is 100% male, but around 95 to 99% we can assume that he is a male if the height is more. So how we can determine this? We can separate this into two classes, that is class A and class B, where class B are considered as a female and class A are considered as a male, and we are taking a discriminant function as height. Okay, which is mm, a normal discriminant function which is distributed with this. So we can say this is a basic example for a discriminant analysis. So first we have formed the groups, that is 50 males and 50 females. Then we have estimated the discriminant function, that is a height. I am moving into the groups, that is males and females. And next we are determining the functions and the variables, that is how many males are there, how many females are there, how we can assume the height, how we can do this. Then I am assuming or interpreting this discriminant function, that is I am calculating the average for this. And with the help of this average, I am predicting that if a height is, say, 5.7, we can say that 5.9, we can say that he is a male. So just like this, we can say this is a basic example of discriminant analysis. Now we will be moving into some mathematical equations and preliminaries. Now we will learn in detail regarding a discriminant function. So before this, if anyone has a question, they can ask me. Before this, if anyone has a question, you can ask me. Am I audible to everyone?
Yes, it is
Hello?
okay.
Okay. So if you have any questions, you can ask me up to the steps of the discriminant analysis. Then I will be moving into the mathematical equations and preliminaries for this.
Okay, sir.
I think there is no any questions regarding this. So I'm moving forward. So now we will be moving into the second point, that is discriminant analysis equations. So let us move into the mathematical approach right now. We have explained the introduction part regarding the discriminant analysis. We have explained what is dependent, what is independent, what are the discriminant function. But how we can generate a discriminant function using some mathematical approach. So we will do a mapping between between the dependent as well as the non-dependent or independent variable. So here we have taken a variable as x, we have taken a variable as y. Now we want to map these two variables uh, by using some function. So we can say it can have a one-to-one function approach. One-to-one function. We have explained in the mathematics, or we learned in the mathematics, one-to-one function. So we will use this one-to-one function approach for doing this analysis equations. So before forming an equation, we have to make a discriminant function for this. So how we can make this discriminant function? We have to map x and we have to map y. Now what is x, what is y? X is a feature vector. Now feature vector is the same thing as an as independent variable. Feature vector is the same thing as an independent variable, and y is acting like an dependent variable. In the mathematical approach, we can say x is a feature vector and y is a label. So how we can do this? So we can form this using a binary classification. Now what do you mean by a binary classification? We have to make sure regarding this. Now binary classification is nothing but classifying each and every group into some parts or into some features. That features can be anything, classifying these groups into features. So we can say the same example I have explained regarding the height approach. So we can say there is a feature that is a tall, there is a feature that is a short, there is a feature that is an average height. Okay, these are the features. We are classifying these features into different types of variables. So we can say a variable x and variable y. This variable y is acting like a dependent variable, independent, and x are the independent variables. So we can say x can be of many parts. Say we can say tall is x1, short is x2, and average is say x3. And we want to try to find the relationship between them. So we can say y. Y can be the predicted variable or predicted tallness of anything, or we can say everything. So y can have w1 x1. Now what is w? W is nothing but the weight. Now we have to consider what is a weight. As I think you have studied about the linear regression, so it is just acting like a linear regression. So each and every independent variables have a particular weight for this. Now this weight can be anything. Say we have I have already explained previously that there are 50 males. So these 50 males have an individual height. Say first height is 5.1, second height is 5.2, third height is 5.3, fourth height is 5.4. So these are the weights for individual data. I have not classified yet, but these are the weights for this individual data. So this w0 are the vectors, or we can say are the references for these data points. So this x1 has a weight say 5.1, this x2 has a weight say 5.2, this x3 has a weight say 5.3. So this, so before explaining the equation for this, we have to assume that if we consider the relationship between the y and x, we have to maintain a vector, or we have to maintain a weight, which will be giving me a reference to each and every features, or each and every data points, or each and every class, we can say. No problem. So that's why this w0, this is a bias. That means we have taken a normal initial position. Say we can say 0. From 0 we are starting. Next, the weights for individual data, and let us consider the overall features of everything is say m. So overall equation can be considered as w0, which is a bias, which is a basic term, w to the power t. This t as I am explaining this t can starting with 1 to m. This t can be from 1 to m. So this t can be from 1 to m. So this is a weight vector and this is a feature vector, which is an independent variable. And this label is a dependent variable. So if we want to compare the dependent, or if we want to make a relationship between the dependent and independent variable, we can say that y is equal to W plus W transpose T, or transpose not, we can say WTX is a discriminant function for a discriminant analysis. This is a discriminant function which will be using me, which is always used for doing analysis for each and every discrimination of the features. So this is the basic equation for the discriminant analysis. So let us take a normal approach. This m can be 1, this m can be 2, this m can be 3, this m can be 4, depending upon, now this overall features are always dependent upon the independent variables. Overall features are everyone dependent upon the independent variables, and these discriminant functions have some name. Okay, so you have to consider a name for this. So if m is 1, so we can say that y is equal to w0 plus w1 x1, because only one feature is there. So then we can say that it is a point discriminant function. So its name is a point discriminant function. If say m is equal to 2, we can say that y will be equal to say w0 plus w1 x1 plus w2 x2. So if this equation is considered behind, we can say that it is a line discriminant function which will be using. So that's why if we consider there are m number of variables, so we can say that it is a hyperplane. So we can say there is a name that is hyperplane discriminant function. Hyperplane discriminant function, which is very much important for the discriminant analysis. And this m is totally dependent upon how many variables you are considering to separate the classes. The same thing if the overall term. Okay, now there are some constraints behind selecting a discriminant function, or there are some boundaries behind the discriminant function. So as we know that a basic function is w0 plus w2 to the power x, so we can say that if y is equal to 0, because we have no dependent variable. Okay, suppose we have no dependent variable, we have only the independent variables. So if y is equal to 0, we can say that it is coming under this category, which is considered as a label 0, which is considered as a label 0. The label is 0 right now. Now if y is greater than 0, if y is greater than 0, we can separate this into different classes. Now y is greater than 0, now y can be 1, y can be 2, y can be 3, y can be 4. Now if we consider that y is 1, that means we have a single dependent variable. Now if we have y is equal to 2, we have multiple dependent variables. So now there is a concept that is a class. We know about the independent variables, whatever the independent variables, how we can assume that lots of independent variables are there. But if we assume that y is greater than 0, now greater than 0 means that more than one dependent variables can be possible. So as I have already explained in the first slide, that if we have more than one classes or more than one groups of data, we can say that it is a multiple discriminant analysis or multiple discriminant analysis. So we can say if y is equal to 1, we cannot say it is a multiple discriminant analysis because there is a single dependent variable. But if y is greater than equal to or greater than equal to 2, we can say, then we can say that it is a multiple discriminant analysis. So that's why it is distributed into this. It is distributed into this. We have taken a separate label for this. So if y is equal to 1, if and only if this is greater than 0, so we can say that greater than 0 means there will be a single class. Now if y is equal to 0, there will be no classes, there will be a 0 class for this. So we are separating into different classes using a discriminant function, that is w0 plus wtx. So we know that y is dependent upon this, so that's why this y is acting like a separator of classes. So take the same example I have explained in the previous slide, that take the same example, that is fruits. This fruits is considered as y. Now these fruits can be a multiple fruits, or these fruits can be a single fruit. So if we have same kind of apples or and all, so we can say y is equal to 1. Now if inside this fruit there are multiple uh, types of fruits, then we can say y is greater than equal to 2, or we can say greater than equal to this. So that's why we are separating this y into different classes using this discriminant analysis or discriminant function. So the role of discriminant function is must before doing some analysis for this. The role of discriminant analysis is must for this. So as we have clearly understood regarding the discriminant function, now there is a second concept behind, before discussing about the types of discriminant analysis. So we have to take care about the covariance also. We have to take care about the variance also. Now what is covariance, what is variance, we will explain in detail. Now we can say I have explained some discriminant function. I have used some discriminant function. Now there is a second mathematical approach, that is a variance and covariance. Now what is this variance? What is this covariance? So we have, let us take one single independent variable, or more than one independent variable, or we can say a dependent variable. We try to implement a graph between the dependent and independent variable. So how we can increment the graph, or how we can determine the graph? So we have some data, like say I am taking some lots of data here. Okay, this can have multiple data in a single container. I have just assumed that if it is there, then it will be dependent upon this. So let us consider, we will start from w0, then we will start from w1 x1, then we will start from w2 x2 and all, and just all. Now we want to separate this with different classes. So here in this example, or here in this figure, I have only separated two classes by using a single line. Here we can say there is a single line, okay, which is separating, say, class 0 here, or class 1 here, or we can say class 1 and 2. So this is separating two classes. Now inside this classes, lots of datas are available. So let us consider that this is w0, this is w1 x1, this is w2 x2, this is w3 x3. Now how we can separate this data? So here we will first try to calculate the average of every data point. Very much important, the average of every data point. So here let us consider 1 2 3 4 5 6 7 8 9 10 11 12 13. There are total 13 number of data points. So first I have to calculate the average of all the data points, then I can separate this data point into different classes. So after calculating the average, now this average is known as a center of mass. This average is known as a center of mass. How we can calculate the average, I will explain also how we can calculate. So first we have to calculate the center of mass. We have implemented the function, but first, before separating with the discriminant function, we have to assume, or we have to first write the average of this. That is, we consider this as a mu. Okay, mu is acting like an average, or we can say center of mass. So we have to calculate the average. Then if an average is calculated, from that average I will try to implement a discriminant function to separate the classes. That means we have taken one average. Average could be a single point, right? So let us consider the average is coming out, say, x5 comma y5. So this x5 and y5, we have to implement this in the discriminant function. So we can assume like y5 is equal to w0 plus w to the power t x5. So we can write like this in the discriminant function. So this discriminant function is separating. So then we can draw a line, or construct a line from that point after calculating the average, and try to implement different classes. So after drawing this line, we have calculated, or we have separated into two classes, say class A and class B. Okay, now I have separated a class, I have distributed the average, I have calculated everything. But what is a variance? Variance are nothing but variance, we can say variance is a measure of the data points which is calculated based on the difference between the data point and mean. Okay, so suppose we try to implement the variance. So this center of mass is distributing the data points into lots of things. Now, how we calculate the variance and how we calculate the covariance? So I cannot say that a line is separated. Okay, suppose this line is separated. So there is a misconception over here that this data point is distributed into two parts. If we assume that there is one data point here and another data point here, and here is a center of mass, suppose. Now center of mass is of equal distance between these data points. So we have to make a discriminant function, or we have to calculate the discriminant function. So these data points are separated into two parts. Okay, so one data point or the same data point is converted into some x part, and the same data point is converted into some y part. So this is what. Now how we can measure this, how much x it has gone and how much y is it has gone. So for calculating that much of thing, we have to calculate the variance of x. That means for this particular data point, I can say that we can assume this. We can say that this data point, this is a half data point. Okay, so how we can assume that how much x is going into this and how much y is going into another class. So for calculating this, how much we are calculating the variance for this. That means if we calculate the x variance, we can assume that for this data point, this amount of variance is going into this class and this amount of variance is going into y class. So if this condition arises for calculating the data points which are distributed by a function, we have to calculate the variance for this. We have to calculate the variance for this. So after calculating the variance, we will try to implement x variance and y variance for this, and we have to implement the covariance. Now what do you mean by covariance? Covariance is nothing but outside of the discriminant function. Suppose up to this there is a discriminant function, after this we have a data point over here. Now how we try to calculate this, how we try to implement this, that which class this data point will be going, whether in class B or whether in class A, how we can assume? But the limit of the discriminant function is up to this. How we can assume that this data will be going into the class A, or how much of data will be going into the class B? Then we have to try to implement the covariance for this. That's why we have to calculate the covariance matrix. So it has some limit. Now, if apart from the limit, there are also some datas, we have to consider those data also by calculating the covariance. And for calculating the variance, the data which are distributed into discrete forms, then we have to calculate the variance for this. So then we have a matrix that is a covariance matrix. So after calculating the discriminant function, we have to calculate the covariance matrix also. We have to calculate the covariance matrix also. Inside this covariance matrix, we have a 2D matrix like this. Suppose for this data point is separated with this, like this. It is cut like this. Half is in class A and half is in class B. Okay, so how we can calculate, how we can assume this? So we have to first calculate the variance of this point, variance of x, then we have to calculate the variance of y, then we have to calculate the covariance if exist between or straight from the line from this. So we have to calculate the covariance also. So after checking the discriminant function, we have to calculate the covariance matrix also. So first of all, now we will explain how we can calculate the center of mass, how we can distribute this into different parts. So I have taken a normal example, average, or we can say center of mass, or we can say mu, everything. So how we can calculate? So let us try to implement this. Say, let us, we have an x and y axis. I have some data points like this. Now these data points are the independent variables, that is w1 x1, w2 x2, w3 x3, w4 x4. Now how we can separate these data points into various types of classes? So we have to first calculate the center of mass. So how we are calculating? Just try to find the average between them. So for the x, we are calculating 3 plus 1, this 1 plus 3, the x part, plus 5 plus 3 by 4. So we have got the point like 3. And the y part of the average like 1 plus 3 plus 3 plus 1, 1 plus 1 plus 3 plus 3, and with anything by 4. So we have calculated the center of mass. Now I have taken, or I have calculated the center of mass. Now with the help of this, I will be try to construct a discriminant function for this. So using the center of mass, I am calculating the discriminant function. So we have taken that this tree or this data point is can have an x variance, this data point can have a y variance. This data point need not have to calculate the variance or covariance. I know that it converts into, or it goes into the second class, and it goes into the first class. These points are goes into the first class, but this type of points which is distributing into two classes, then we have to calculate the variance and all. So this is the basic average calculation for uh, calculating the center of mass. Now how we can calculate the variance? How we can calculate the variance? So there is a specific formula for this. If you try to implement the x variance, that means the horizontal part, we try to implement the x variance, we will try to take all the x coordinates of the data points and try to do a square part of this. Okay, so as we know there are 4 data points, that's why I have taken 1 by 4. If we have 5 data points, we will be taking 1 by 5. But here in this example we are taking 4 data points. So these 4 data points, how we can calculate? So we are taking the x coordinates like this. So 1 by 4, then we are doing a sum of the squares of the x coordinates. So first is -2, that is -2 whole square, plus 0 whole square, plus 2 whole square, plus 0 whole square. So I have taken this x variance is coming out to be 2. So 2 can be an x variance. So this is a formula for x variance, the simple thing. Similarly for the y variance, we will be taking y coordinates for each and every data point or for each and every data, and try to implement this using the same formula and doing the sum for this. So we can say 1 by 4 but taking the y coordinate at a time. So this could be a y variance. Now if I calculate the x variance, if I calculate the y variance, we can easily identify. Here we can say that x variance is coming out to be 2, and here we can say y variance is coming out to be 1. So we know the variance or the limit for this is 1 comma 2. So for this we have separate, we can, by using the variance also we can separate the data. So if we have small x variance and small y variance, if we have small x variance and small y variance, the data will be looking like this. The visualization part will be looking like this, which will be taking me lots of time to separate those data between the classes or between different types of classes. If we have large x variance and small y variance, this is also taking me a lot of time to separate those data between the different classes. If we have small x variance and large y variance, so these are the 4 constraints behind separating into the classes. So we will be applying the discriminant function for each and every case. So here it is little bit easier to distribute into different classes. As I know this is coming out to be let us say this is coming out to be a middle part for this, or we can say it is a center of mass, we can assume this. So using this we can separate this data. But here in this case we cannot determine which will be the center of mass. So we have to calculate the average of each and everything, and then we have to separate the data. Similarly, if we have large x variance and large y variance, this is the best case for doing a discriminant analysis. Why? Because here we have clearly understood that this is separating me into different classes, or this point or this type of point is separating me into different classes. We can visualize using large x variance and large y variance. So first we have to calculate the function, we have to calculate the covariance matrix, and we have to calculate the variance. Okay, now this is the same thing if you have a same variance. Suppose if you have a same variance, so there will be this type of thing, there will be a separation for this. Now if we have a covariance, now how we can calculate the covariance? So just we have to remember that while doing the discriminant analysis, we must have large x variance and large y variance, so that our visualization could be easier for us for doing some analysis. So how we can calculate the covariance? Next, we have to calculate the covariance. So similar thing, if we are taking those co-points or those points, what I am doing first, I am multiplying this x coordinate with y. You can see in the figure that first I am multiplying each and everything. That is -2 into 1. First we have considered this -2. Then we are multiplying this, that is 0.1, that is 0 coming out to be this 0 dot minus 1, 0 dot minus 1, 2 dot minus 1 minus 2. So we have taken we have first step for finding covariance is like this. We have multiplied x coordinate with the y coordinate and taken some example. So we have given an example like 0 to 0 coming out -2, 0 0 minus 2. Now we will sum up this and try to calculate the average for this. So this is what a covariance is. This is what a covariance is. This is what a formula for finding the covariance. First we have to uh, multiply x coordinate with the y coordinate, then we have to find the average after calculating the answers. So this is a simple thing. Okay, this is a simple thing of finding the covariance for this. So here also the same thing, the covariance we try to find this. Now if the covariance will be coming out negative also, the covariance will be coming out 0 also, the covariance will be coming out positive also. This covariance is coming out to be negative, this coming out to be positive, this coming out to be 0. Now if the covariance is coming out to be 0 or very small, the graph will be looking like this. The graph will be looking like this. And if negative covariance is coming, so we know that there are 4 quadrants. So basically the down quadrants have some negative values, so the graph will be coming like this. We are separating this into multiple classes, or we can say a single class A and class B. So the graph will be looking like this, coming downwards, and positive, the graph will be looking like this, coming upwards. So this is what a positive covariance is, this is what a negative covariance is, and this is what a zero covariance is. So these are some mathematical preliminaries and some concepts for determining a discriminant function, or try to analyze those equation and try to implement this in the while doing the analysis. So I have explained each and every uh, formulas. These are the simple formulas, the same formulas. Okay, I have calculated the mean or average or anything. I have calculated x variance, I have calculated y variance, I have calculated covariance. Now after calculating x variance and y variance, directly we can generate a covariance matrix, that is variance of x, the same formula I have explained, the variance of y, covariance, and the covariance. These two covariance are the same thing. So this could be a covariance matrix. So while doing discriminant analysis, we have to implement first a discriminant function, and then we have to implement a covariance matrix. These two are the vital mathematical approach before determining any analysis. Now if you have any doubt, you can ask me. Now we will be moving into, now we can easily clarify those, or we can easily try to implement the types of discriminant analysis. So I will be doing some implementation or doing some coding and all for doing a discriminant linear discriminant analysis. So basically we have three types of discriminant analysis. So first part we will be doing, that is a linear discriminant analysis. Now, what do you mean by a linear discriminant analysis, and what do you mean by a quadratic discriminant analysis? So first we have to implement, or we try to explain that what is a linear discriminant analysis. So as we know that we have explained, or we know, or we study from the childhood, that there is a linear equation. We have a linear equation of line as well. So from that concept, this linear discriminant analysis approach comes in hand. That is, this is used when all the predictor variables. Now what do you mean by a predictor variable? Predictor variable is nothing but they are the same thing as an independent variable. They are the same thing as an independent variable. These are the predictor variable, they are the same thing. So when we can do the linear discriminant analysis, whenever all the predictor variables are continuous, that means whatever the independent variables we will be taking, they will be in a continuous fashion, as well as they have equal covariance matrix. These two terms are very much important for linear discriminant analysis. These two terms are very much important for the linear discriminant analysis. So we have a predictor variable which is always continuous, as well as each and every variable has equal covariance matrix. Then we can say that this comes into the category of linear discriminant analysis. So we have taken a normal overview of this. We can say linear discriminant analysis. We have a function. This line is nothing but a discriminant function which is separating the data points into two classes, A and B. So as we have already explained that these two terms are very much important, that predictor variables or the independent variables must be continuous, and and it have a equal covariance matrices. So it enables us to draw a straight line. As we know that it is continuous, we can easily draw a line. Here the line is acting, which is separating two classes into data points. Easily we can classify the data into different classes using a function. Why? Because we have continuous predictor variables and have equal covariance matrix as well. That's why we can distribute into different classes for this linear discriminant analysis. Okay, so how uh, this linear discriminant analysis is going to take place? So I have distributed into something, say we can say that these are one type of data and these are different types of data. But which data? Suppose we have a black circle and we have a black circle and we have a red circle. So this black circle is one dependent variable, say x1. This red circle is one another independent variable, say x2. So this x1 and x2 are distributed into different forms, we can say, but they are continuous. You can say that they are continuous. First this, then this, then this, then this, and all. These are dependent. Now, if you want to draw a line between them to separate these two classes, that is where these black circles will be going, where these red circles will be going, in which class it is going, we have to take a discriminant function for this. So how we can take this discriminant function as y? The same thing, y is w0 plus wt to the power x, the same equation which will be taking me like this. So here these independent variables have different features. uh, we are separating this. So how we can separate? So basically what it is doing maximizing the distance between the mean of two classes. That means if we want to take the mean of first class, the mean of second class, overall mean, I have converted this into two classes using the discriminant function. But how we can use the linear discriminant analysis? After creating a distribution function or discriminant function, I have observed that in class B there are 4 data points which are coming. In class A there are 7 data points which are coming. Now how we can implement this in a linear discriminant analysis? We can implement this like uh, by calculating the average distance between them. Okay, by calculating the average distance between them. Now as we know that these dotted lines are a distance of that data point from the center of mass. This is center of mass, that's why a function is generated. So we will calculate each and every distance of each and every data point for classifying into two categories. So what it will do, it maximizes the distance between the means of two classes. If we calculate that mean, okay, say mean is coming out to be 3 and here the mean is coming out to be 4. So the distance between them, the distance between each and every distance between each and every data point can be in the class, that is it has a distance say 4, say 4 comma 4, which will be the nearest data point. It will be calculating like this. Now we have to minimize the variance also. We have to minimize the variance also. Now three conditions must be satisfied for linear discriminant analysis. Predictor variable should be continuous. Minimum variations of each and every class must be there, and each and every class we have to find the mean for this, and as well as we have equal covariance matrix. So this linear distribution can be done using a discriminant analysis, or it is a part of the discriminant analysis. It separates the independent variables into two parts just by calculating the mean and maximizing the distance between the classes and the mean of that data. Here the mean is acting like uh, center of mass, we can say. So I have implemented one thing. So before implementing one thing, I have to explain that I will implement this linear discriminant analysis for iris data classification. I want to classify iris data. Now, what do you mean by iris data? It is just used to identify a plant species. It is just used to identify a plant species based on the following parameters, that is sepal length, sepal width, petal length, petal width. So here the features, whatever I have discussed, the features are sepal length, sepal width, petal length, petal width, and the species is identified just after the and the species which is acting like a label. And I have already explained in the previous uh, uh, slide that what are labels and what are features. I have already explained here that this is a label and these are the features for this, or these are the uh, normal independent variables for this. So if we assume, if we try to implement a linear discriminant analysis using sepal length, sepal width, petal width, then we can easily identify, or we can easily separate the classification of plant, what type of plant it is. So basically, if the sepal length is, suppose I have taken this thing, if the sepal length is around 5.1, or the sepal width is around 3.5, or the petal length is around 1.4 or 0.2, it comes out. Now if you try to find the linear discriminant analysis, then we can say that it will be comes under the category of setosa. Now what is setosa? Setosa is a scientific name of a particular plant. Versicolor Versicolor is also a scientific name of another plant, and Virginica is another name of plant. So I have taken here three dependent variables. I have not taken a single dependent variable. I have taken three dependent variables and four independent variables. Or we can say I have taken three different species and I try to predict the values after calculating the sepal length, sepal width. I try to implement that what could be the uh, genre, or what could be the genre for what could be the classification criteria for this plant. So let us say the petal is coming out to be length and width. After calculating the area, it is coming out to be say 3 point something, and the sepal is coming out to be say 4 point something. So it comes under the category of what? It comes under the category of setosa. So there is one pre-trained data. There is one pre-trained data where we will implement the testing and training for this. Okay. So now I will be implementing uh, a Python programming for this. How we can generate or how we can use the linear discriminant analysis for this. So basically we can say that there is a predictor variables and there is a response variable into two or more classes. I have already explained that this response variable is what? This response variable is nothing but a label, and a predictor variable is nothing but the sepal length, sepal width, and all. Now you have there are total 5 steps when we move into the practical approach, and I try to implement the linear discriminant analysis for calculating the data classification regarding the plant species. So we have to first move into the 5 steps. First step is nothing but load the necessary libraries. Now you have already learned about what are the Python libraries, which in which package which libraries are there. So here we will specifically use some libraries like sklearn, matplotlib, pandas, and numpy. So basically, 4 libraries are used behind this, and we will try to build a model which will tell us that whether this plant is a setosa plant, or whether this plant is a versicolor plant, or whether this plant is a virginica plant. So it totally depends upon me with the independent variables that will be calculating me like as length, as width, petal length, petal width. So the our main objective is to classify or identify what type of plant species it is. So we have to develop one model for this. So for developing this model, we will use a linear discriminant analysis, which will try to separate this into different classes of that model. So this sklearn library has a model that is linear discriminant analysis. Already this it has a model. You do not have to calculate the covariance, you do not have to calculate the variance, you do not have to calculate the center of mass. It will be handled by the compiler itself. So Python is making me available of this model that is a linear discriminant analysis. Just I have to take a function and try to call this function and take a model and try to implement this. So first and foremost, we have to load the necessary libraries, that is sklearn, matplotlib, and pandas. Matplotlib is used to plot the data or visualize the data, whatever the data we have taken. Pandas is used for the numerical calculations, or for creating a data or data frame, we can say, or data set, we can say. Numpy is used to generate a particular matrix or particular thing for this. Okay, so this is the thing, and sklearn is used for the discriminant analysis. This is very much important library. So first of all, this iris data is already available for the Python compiler. I will directly call this iris data using the function that is load iris. The data is already available uh, uh, in the website, and I try to predict that what type of plant species it is. Okay, I try to implement that what type of plant species is. Okay, so next, this load iris function is used to load the data set. Now this data set has this type of thing. So first, this data set is converted into data frame. You have studied about the pandas library, which is used for converting a data set into data frames. Data frames are nothing but the same thing, that is the data points. Whatever with the thing, these are the data points, or we can say these are the independent variables for creating this. So we can say that after loading the data, I try to convert this data into the data frame, or in a particular tabular format. I try to implement those data. Now we have some columns, that is as length, as width, that is sepal length, sepal width, length, petal width, target, and species. So I try to observe this data first. So our second part is to load the data and observe the data. So how we can load the data using load iris method. Then I have tried to convert this into the data frame, and using df.head, command, I tried to observe this data. Okay, little amount of data, all data are not available, little amount of data I am observing that we have this type of data. That means if we have a sepal length like this, a sepal width like this, or p length or p width like this, we can separate this. Next is what? df.index. Now what do we mean by index? Index is nothing but the total number of observations in a data set. That means our total number of observations are 150. Here it is only showing me 5, but there are total 0 to 149 amount of data. That is iris data set, we can say. There are total 0 to 149 amount of data. After doing research of this data, it is coming out to be like this. We have a data set, and I want to use this data set and try to implement this data set using a linear discriminant analysis. So using df.index, we will find total length of the data, that is 50. So as I already explained that we have an x, as I know that x is an independent variable. So these are the predictor variables. Predictor is nothing but the same thing. These are the independent variables, that is sepal length, sepal width, sepal petal length, petal width, and y is a dependent variable, that is a species. Now this species, I want to convert this y into different classes. So just I am taking a normal uh, approach of this. I am taking just normal approach. I have x, this x is converted into 4 parts, that is sepal length, sepal width, petal length, petal width, and I have a y which have been converted into 3 parts. I have to make a discriminant function so that it is converting me into 3 different classes. Okay, so using these 3 different classes, I can implement that what type of species can be. So that's why these 3 classes are the Setosa, uh, versicolor, and the Virginica. I have converted into these 3 classes. So just I have taken these independent variables from the data. I have taken df. What is df? This df is nothing but this df is the data frame which I am taking. So this df has some independent variables, and this df has some dependent variables. Now I want to try to fit this into the model, or I want to create a LDA model. So I have taken a normal variable as model, and I have directly written as linear discriminant analysis. So this model is doing everything whatever I have explained in the mathematical equations or preliminaries, whatever I have discussed. So this model is distributing me into a linear discriminant analysis. Then I want to fit this model into x and y. Okay, now this linear discriminant analysis is taking place between x and y, that is between the sepal length and the species. Now I already explained this. Now after doing some discriminant analysis, there are some accuracies which are coming like 0.98. Now why this accuracies is coming? So here is one more concept, that is the step 4 of the linear discriminant analysis, that is a k-fold cross validation. This is very much important. So before explaining the step 4, I will explain that what is a k-fold cross validation. So k-fold cross validation is nothing but, just I have to take this. Just you observe this figure, that I have lots of data. I have currently not classify any data into some different parts. I have not classified into any parts. So what I will do? So you have learned I will train those data. Then I will test those data. So k-fold cross validation is nothing but, first it is scanning, just like a window pane, we can say. Whenever we open the window, just like a pen, we can say, whenever we slide the window, you can see in the real life, that is there are a sliding windows. Okay, so just I have taken a test data as a variable, as a sliding window variable, where there are say 5 number of data. which are not distributed into many classes. Okay, I know that this red are in different class, this green are in different class. Just I have scanned, I am trying to scan this data. So in the first iteration, first I have taken 5 amounts of data, I have folded this data and taken a variable as test data. I am testing this data. Okay, and these are the training data. These are the training data. So after applying the linear discriminant analysis, I will do a k-fold cross validation. That means what? I will be doing LDA or the analysis between only these 5 points. Why? Because in the single window pane, I have only taken these 5 points. So that's why it comes under the step 4 of the linear discriminant analysis. So we try to test this data using LDA approach. I try to find the variance, I try to find the covariance, I try to implement this. Okay, after folding this data is trained, this data is tested. Okay, not trained, this data is tested. After this data is tested, just like I am sliding the window, in the second iteration I will try to implement this in a LDA approach. So right now this test data is coming here, and I try to implement LDA approach. This is already trained, this is already tested, this is already tested. Next, the same thing, the same iteration I'm going, it is tested, and at last, the last one is tested. Each and every data is tested. After that only we can separate this data into different classes. Why? Because I have tested linear discriminant analysis. Each and every data point I have tested. I have tested each and every data point. So I have taken an iteration, say k. At k number of iteration, it is completely folded. That means overall it is validated or tested. That's why a term is there, that is a k-fold cross validation comes in hand. Okay, so that's why I have taken this fourth number step, that is uh, just a minute, that is this folds and all. So it is taking me 10 number of iterations and 3 repeats. Now what is this 3 repeats? These 3 repeats are nothing but the 3 classes. These 3 classes are already been tested, already been trained, because I have taken a LDA, and our accuracy is coming out 98%. If we apply this folding or k-fold cross validation technique. So that's why the name is there, that is repeated stratified k-fold. This is a function where we have to take 10 number of iterations and we have a 3 repeats at a random state. Now random state is nothing but the steps. First part, first 10 will be observed, second part, second 10 will be observed, or second trend will be tested, just like this. Next, we have a cross value score. We will find the accuracy, that is a cross value score. So we can say that we have trained the data, or we are getting like a 98% accuracy. Then we can predict that a new flower, suppose a new flower, I have taken this as a new flower. It is not in the data set. I have just normally taken a new flower, and I observed that a a sepal length is 5, a sepal width is 3, a petal length is 1, and a petal length is petal width is say zero point 0.4. And I try to predict that uh, flower. So it is giving me an answer like it is a setosa flower. So this is what a linear discriminant analysis is used. This is what a linear discriminant analysis is used. First, we will give the data, then we will apply a cross validation technique. After applying the cross validation technique, we will find the accuracy. If the accuracy is coming out more than 65%, we have to remember that if the accuracy is coming out more than 65%, then only we can apply, or we can predict the accuracy of a particular thing using a linear discriminant analysis. So here just I have taken a normal approach. I have taken a normal data which is not present in the this. It tries to compare, or this tries to discriminate this data and tries to predict that model. So that model is coming out to be a setosa. So we know that yes, it is having this petal length, or having this sepal length, or having this widths. It comes the category, that is, it is a setosa flower. So lastly, how we can say that is a setosa? Okay, no problem. We have predicted because the 98% accuracy is there. But how we can uh, implement this into a visualization part? Whatever the data we have taken, whatever the data we have observed, how we can implement this in the visualization part? So here we will use the library that is a matplotlib library. You have learned already what is a matplotlib library, where x is a data and y is a target. Target means a type of, that means a predicted data whatever we have taken. Okay, so first we have to define the data point, whatever the data I have taken. Then we have to create the LDA plot for this. Now what is the plot for this? Red, green and blue. I know that I have to take three dependent variables, that is setosa, versicolor and virginica, which is giving me a classes of data which is predicting using the using the LDA approach. So we can say that we have created an LDA plot. The red is signifying me a setosa part. The green is signifying me a versicolor part, and a blue is signifying me a virginica part. So we can say we can plot like this. We can say we can plot like this. So this is a normal classification between this. So as we know that there are three classes, so we must have a discriminant function for this. So here the discriminant function has four types of independent variables, that is this thing: s length, s width, p length and p width. So here we can observe that, or we can try to implement that what type of flower species it is using an LDA approach. So this is a complete implementation of Python regarding this, how we can implement this. Next is uh, just a quadratic discriminant analysis. Quadratic discriminant analysis means we have more than two uh, dependent variables. That means what? We have more than two dependent variables. As we know, it is a linear discriminant analysis has the same covariance matrix. So also for the quadratic discriminant analysis, we have a same covariance matrix. Same covariance matrix makes it more flexible, requiring more parameters and all. But we have here we have more than two dependent variables. More than two dependent variables. The thing is same, we are doing the same analysis, we are doing the same thing, same type of analysis, but we have more than two discriminant dependent variables. Also we have more than two discriminant function as well. So here we can say in these three figures, this line is separating into two classes. That means we have a single discriminant function, we have two independent variables. Similarly, in this also we have two dependent variables, two independent variables and one single discriminant function. But in quadratic, we will be more precise into precise way to separate the classes. Okay, now I have taken one normal example for this. This blue have the same features, but inside these blue color balls, there are some deep blue color balls. Suppose I want to predict that deep blue color balls. So how we can do this? We cannot do this using the linear discriminant analysis. For more, we have to do this using a quadratic discriminant analysis. That's why I have said that we have to take more than two dependent variables and more than two discriminant function to further predict the exact values for this. Now I have taken a normal example like different types of tumors. A, B, C, there are the tumors. So these tumors have different types of classes. So these are the dependent variables. Now we have a head tumor, we have a normal tumor, we have anything tumor. Okay, I don't know what type of tumor it is. So to signify the type of tumor, I have to use a quadratic analysis approach. If we use the linear discriminant analysis for identifying the tumors, we cannot identify the accuracy for that tumor, that what type of tumor it is. We cannot identify that tumor. So basically it is an example of medical diagnosis. Okay, so that's why if you want to classify that what types of tumors are that, so we will use the quadratic discriminant analysis. So in this example we can say there are two discriminant function. That's why it is giving me two lines, which is trying me to implement into three types of categories. Suppose these blue colors are under the category of class A, these red colors are the category of class B, and this deep red and deep blue are the coming under the category of C. So using the quadratic analysis approach, we can determine that whether this classes or this size and shape comes under the class A tumor, this size and shape if persist comes in the class B, and this size is and shape if persist comes in the class C. So we can say there is a normal example I have taken, that is a tumor analysis. Actually, doctors are also using this medical diagnosis or the tumor analysis. So there we can say that a quadratic discriminant analysis are taking place. So this can be a normal approach. This can be a normal approach. So also you can see here the iris data set. Suppose I want to setosa. Now what type of setosa it is? Setosa can be anything. Okay, setosa can have say 10%, say 90% setosa, or we can say 50% setosa and 50% versicolor. Suppose some data points are there which are suppose 60% setosa and 40% versicolor. So in which category it will be coming? So there we will use the quadratic discriminant analysis for this. Okay, the accuracy must be maintained. The same thing here, we will use the same thing. I am taking the same example. I am showing this. The same example I am taking. Everything is same. Everything is same. I have to load the necessary libraries. I have to load the data. I have to convert this into the separate length and all. I have to calculate the index for this. But in the step 3 and in the step 3 comes into the hand for the discriminant analysis. That is, instead of using linear discriminant analysis, we will use a quadratic discriminant analysis. The remaining thing is the same thing. The remaining thing is the same thing. We will use a quadratic discriminant analysis to distribute uh, further. The setosa is further distributed into two class, or the versicolor is further distributed into two classes and all. So we can use this. So this is what a quadratic discriminant analysis is. Next is, this is just a normal example, that is a regularized discriminant analysis. Regularized discriminant analysis is nothing but it is basically used to classify images and videos. Now how we can use this analysis to classify images into videos? I am just taking a normal example of a Google map. Suppose I'm taking an example of a Google map where it is showing me some green colored areas, some green colored areas. Say it is a green colored areas. In another part it is showing me a black orange colored areas, that is. And in another Google map it is showing me uh, blue areas. So how these are the classified? Now what are the classifiers for this? The classifiers are, the blue colored areas are the rivers. So this river can be one independent variable. Green colored areas are the trees or the plants, whatever be the there in the Google map or the satellite map, whatever we are seeing. So this can be one dependent variable. And this yellow or brown colored are the areas, or we can say are the lands and all. There is one another black section also which is showing me a road for this, road lines. So that can be also one class for separating that thing, that thing is a roadmap also. So this thing is also used for the regularized discriminant analysis. The regularized discriminant analysis have more than
five or more than six discriminant functions. And discriminant or the independent variables, more than three or more than four discriminant variables or independent variables, and dependent variables can be more than three also, more than three also. So so this is basically for doing image analysis or image classification or video classification. So here in this example we can say that, let us take a satellite example. So what are these classifications, how we can classify this image as well? So we can classify this email. You can see here this classification. In this classification we can say that the airlines, these are the airlines. So airlines have been classified into different uh, class. Suppose this is a class 1, that is airfield. These are the beaches. Okay, beach, that is the road and the road, so road, not sand and river and all. So it is separated into beach. And parking space, these parking spaces are separated into another classes. And the game space, that is a stadium and all, and tennis table tennis stadium and all, these are separated into this. So here we cannot use the quadratic analysis, because lots of analyses are there, lots of images are there, which is further classified into further different images. So that's why here more than one discriminant functions or more than three discriminant functions can be used. And different classes can be used for this. So it is the best example, that is the image classification is done for the regularized discriminant analysis. So this is the third last part of the discriminant analysis approach. So we move into the final part, that is the applications of the discriminant analysis. So how right now, where these applications are moving or where these applications are going on hand, okay, where these applications are running right now. So basically to identify the severity of diseases. Now lots of diseases are coming in hand. Right now corona is taking place, and further more viruses are coming. Okay, now how we can separate or we can identify the diseases? So we have to take the symptoms for the disease, which is the main factor. These symptoms can be acting like an independent variable. For this symptom, this disease is arising. For this symptom, this disease is arising. So in this example, I have taken that a person is just sitting, a person is only standing, a person is just walking. Just I have taken this. After walking, he has some blood pressure like more than blood pressure like this. After sitting you have a blood pressure like this, and after standing it has a blood pressure like this. So from this blood pressure I can identify that what type of measurement or what type of pressure he has. Just I have taken an example, what type of pressure he has. Either he has a high pressure, either he has a low pressure, or either he has a normal pressure. So this high, low and normal are further classified using this approach. Next, some symptoms can be there. After calculating the heartbeat, it suppose these blue lines have the some symptoms, like it is moving upward, then it is again moving downward. So between this and this, there is some symptom which is arising. So that symptom can be also identified using the discriminant analysis. So we can say medical diagnosis. It is very much useful. It will be very much useful in the future for diagnosing the patient, using lots of symptom and using the approaches like the analysis and all. So we have taken a normal example, that is a binary classification. Just I have taken that if he have a score 0 or analysis it is coming out 0, he is healthy, or predicted score is coming out to be more than 0, he is not healthy. So just this is a normal example. Can we say it is a discriminant analysis? Classify the type of illness that a patient suffers. It can be also one application of the discriminant analysis. Next, biological object classification. As I already discussed, right now, iris data classification. I have taken a flower. Okay, I have taken an anonymous flower. I am calculating the sepal length of that flower. I am calculating the sepal width of that flower. I am calculating the petal length of that flower. I am calculating the petal width of that flower. After calculating this, I am applying linear discriminant analysis. So then I can say that it comes under the category of setosa or something. So this can be a biological object classification also. Taxonomic groups of people also. Suppose In this area, the height is average height is coming out to be 5.5. So it must be in this area. Okay. In this area, the average height is coming out to be 5.6. We are predicting that using the LDA approach. So this can be a taxonomic groups also. Right now, currently, the most important part, that is the pattern recognition, is also taking place or using this application, that is the discriminant analysis approach. He is also using the discriminant analysis, that is the pattern recognition, that is face recognition algorithm. Now what is this face recognition algorithm? We have a face, we have some eyes, we have some nose, we have some lips. So each and every eyes have some key points of data. Okay, the distance between these key points can be less, the distance between that key point can be more. So that key points, after calculating that key points, we are calculating those data points, so that each and every key points are acting like a predictor variables. And after applying those discriminant analysis approach, he is assuming that whether that data or whether he is a human or not. So that's why that data points, whatever the data points he is arising, that is a biometric. Okay, face biometric. It is also using a discriminant analysis approach, face biometric. How he is doing the analysis approach? First, he calculates the key points. Suppose we have two persons. The person one has a key point of eyes, or the distance between the two eyes is say 3 centimeter, and another person has the distance between eye say 3.2 centimeter. And again, only the distance between I not, each and every variables are also different, to assume that he is an exact person. So that's why this 3.2, this 3.2 are acting like an independent variables, and then they are applying the discriminant analysis and calculating that the face of that person is this, the predicted face of that person is this. So that's why we can say that it comes under the category of the uh, pattern recognition, that is a face recognition. Last part, that is we can say that earth science, this is also used. We can say that a hyperspectral, you will study in detail about the hyperspectral images are very much important nowadays for calculating that exact. Suppose there is a lower mental, there is a upper mental, you know what is crust, what is mental, what is core, and what is all. Now if the mental thickness of in this particular area, the thickness of that mental is less, so the chance of earthquake is very much high for this. So this chance of calculating the earthquake or predicting that whether that earthquake will take place or not, it is also used, or they also use this discriminant analysis approach. They are identifying the patterns, like what is the exact temperature behind that area at that particular location. Inside this, what is the exact distance of the mantle, what is the exact distance of the lower mantle. Okay, so this crust, mantle, lower mantle, outer core, inner core are acting like an independent variable, and the earthquake, the floods, and all the prediction of something, that flood will be taking place in this area because the rise of sea level is taking place. So we can say that that can also comes under this category of discriminant analysis. So we have more than one independent variables, or we can have more than one dependent variables, that is earthquake and flood. So that's why this is also right now being used in the discriminant analysis. So this is also an applications of the discriminant analysis. Basically, it is known as an hyperspectral images, assumption of the hyperspectral images, or assumptions of the hyperspectral videos. So up to this, we know the details regarding the linear discriminant analysis. What are the mathematical preliminaries behind the linear discriminant analysis? What are the steps regarding the regarding the discriminant analysis? How LDA is used, in which data set it is used, I have explained in detail about by checking this. What is the discriminant function, how this discriminant function is used in different parts, or how this covariance is calculated in different parts. So I will be giving 5 minutes or 5 to 10 minutes. You can ask me any questions regarding this applications for this.
I will be giving only 5 minutes. If you have any doubt or if you have any questions regarding all the topics I have covered till now, you can ask me.
So I had a query regarding this covariance of covariance matrix.
Hello?
Regarding this covariation map, covariance. When you say
Just a, Mhm. I have to explain about the covariance, right?
I had just a query, and